first, because we use that material and assign it to the connections. And to do that, I'm going to go into material, into the material manager. And then you can just go under hardware, thereby connector. And we can sort of create it there because you're going to use it in the future again. So what I'm going to do now is I'm going to say here on the top, new. Type is connector. Name is whatever this, what's this called?
It's called the RD12.
OVO RD12.
But remember, you got a male and females in it.
Yeah, the system is, the whole system is.
One connector model.
Okay, description.
Just OVO RD12, yeah. And then next, unit of issue, we can just set as each, and then type, very important, connector. If it's not a specific thing that's mentioned here, just name it connector.
So type will be connector.
Connector. And then we say finish. Then we got our material now. Now, before we go and modify all of this, we need to bring in the model first and assign everything how it needs to be. So to do that, select the ID and double click on it.
The ID, okay.
It's going to bring you open this page.
So that's almost, that's a properties, okay.
Yeah. Then you'll see here in the top right corner, there's a model option. If your screen is very small like this, it's not going to show properly. Just select the model.
Okay.
And that's going to bring us into this page.
Okay, like a T.
Yeah. So it's just an example side and an example shelf. This is what we're going to use now to bring our model in and to assign our machine.
So just play with your screen so you can get another 3D view. Correct.
So to bring in the model is very easy. It gets tricky where you need to place it correctly with the correct equations. There's a few set equations that you can just always use over and over and over again to get your models perfectly dead center. So we don't bring, when we bring in the model here, we do it on this green block here. That's the work plane. So the connection that we work plane, primary work plane.
So that's important.
Correct.
So you use it as a placement tool.
Correct. Because in theory, the connection manager that we use to set up the connections doesn't work with the model that we bring in. It works with that work plane. So if we place the connector correctly on the work plane, it'll always place correctly in our connection sets. Right. To bring in a model, very easy. So you'll see here on the left, we have assembly, left end, shelf, primary work plane. So all I'm going to do is I'm going to select my primary work plane, and here by view mode, I'm just going to select left. Drop down, and then just select left. Okay. And it's going to show me like this. Now press anywhere on the screen. Anyway, now you'll see the add hardware option there on the top. It's blanked out. Okay. You can't select it. You have to be in a specified view mode with primary work plane selected before that even becomes available. So then I can now go and say add hardware.
So we choose left.
I just choose left because then you can see properly where it gets placed.
Okay, you want minus one.
Right, then you in add hardware.
Yeah, so I don't have mine, so
So
You
select primary work plane.
Yeah.
okay.
Now it's there. Only once you select it.
Only once you're in a view mode with your primary work plane selected will that become available. So then you can just go to where you saved your model now.
Correct.
Just find mine quickly.
This time I'm seeing the SKP
SketchUp file.
SketchUp, okay.
And then just double click on your connector model.
Yeah.
Then it'll look like this.
Yes.
Now we just need to get this to orientate correctly. So sometimes it'll show like this, but it'll come in horizontally or the other way around or such. So normally I just bring it in the first time like this, and I'm just going to say, okay. Then you'll see it places the model there. Now I can clearly see that is not correct because I wanted to lay like this.
Okay, we'll just turn mine.
You need to bring it in correctly, rotate it.
You
Yes.
gotta like shift it.
Yes. So go back to your view mode left. Then you'll see here under primary work plane, there's this item here with the funky words.
Okay.
Select it, right click, delete.
Okay.
Right. Then I'm going to go select my primary work plane again and go into add hardware again.
Okay.
Open your model again.
Okay.
Now we just need to rotate it correctly so that it lays correctly, because we know now if we bring it in like this, it's going to place it like this, so it just needs to fall backwards. So fall backwards. And there we use this. So we can use the flip X function to just rotate it correctly.
Or flip one.
No, to flip it to the correct side.
So it's is the horizontal plane. In this case.
X is horizontal, or in certain cases, depending on how you drew your model, Y might also still be your horizontal plane. So if just flip it so that it looks like that.
Okay.
Okay, just press X twice again.
Okay.
All right. Then we can go ahead and say OK. There we got our model brought in now. So now we need to bring this model in so that it sits correctly between the parts. So the way we do that is we can now just go back to left again. The equations that we need to do now is very simple, because I need this whole thing here to always sit in the middle here and in the middle there. So to do that, we can modify it with equations. So if you select the part here on the left, you can change the name there under description. I'm just going to write there model, so that it just shows up correctly here on the drop down.
Okay, so we're changing the description to model.
No, well, the purpose use model, but then remember change that to use it. Okay, which is the
No, it's just, this is just to reference it in the model here.
Okay.
Finish type and texture mapping, we don't have to worry about, because this connector is always going to be hidden away, so we don't need a texture on it. Then we can go and work now with the X and the Y axes to place this now correctly. Now, the equations I'm going to give you now, write it down or save it or something, because it's always going to be the same. On my x-axis, it's going to be minus dx / 2.
X plus. You said what? Minus
Minus dx divided by 2.
X.
So what that does is it takes the dx value of the part, which is 34.5 or 30, and it divides it by 2, and that value, it moves it left. So now my part here is dead center, 48.5 from that side, 48.5 from that side.
Okay, so let me add the equation minus dx divided by 2.
Okay, so just check here. I don't know if I showed you now correctly. You don't add it here.
Oh no, I added it on that.
There we go. And then you say equation,
Yes.
correct. All right. Then for y can get a little bit tricky depending on the model that you have. Y is either minus dy divided by 2.
Y-axis minus dy divided by 2.
Which is not correct. So I'm just going to check something quickly. Minus dy. Puts it there. And I'm going to say minus dy divided by 2. There we go. So on the y-axis, it's going to be minus dy minus dy / 2. The reason why we add equations on this and not a locked value is because this equation works with the thickness of the part. So if I set now just there, minus 14.1, on the reference panel that's here, which is 19 mil thick, it would have been correct. But then I add a 16 mil panel in my job, and which then basically just goes to there, then it's not going to be center. It's going to be offset.
So currently we working on the 19 one
Yeah, this is just for the reference.
reference.
For the reference, yes. But the equation, what that does is it allows it that even if I go and have a 16 mil or 18 mil or whatever panel size, that will still place in the middle, in the center of that part.
Okay.
So your X and your Y axis always has those two equations. All right.
Okay, so
Now
we do on y, so 1 second. So equation is
minus dy,
y divided by
no, minus dy,
dy
minus dy divided by 2. All right. Then we can go just here to 3D mode, to view mode front, so we can see it from the side. Now, I want this whole piece here to be inside into the side here. So the way we do that is we work with the Z value here. So I'm just going to check here value and I'm going to see, okay, so that is 26, I think. So the Z value doesn't need a equation. There we could just go and say minus 26.
How are you doing that we pull the line to see?
Oh, measure.
Oh, measure. Okay. So you're pulling it from
Yeah. So you don't have to measure. I just wanted to make sure what the value is. You can just press on the Z value minus 26.
okay, so you this is front. Okay. My instructions on the left, it's now showing something different.
That's what it's supposed to be.
Okay.
There we go. Select your model. Okay, just go out. That's happens sometimes. Just return, say yes. Go into the model again.
Is that just above?
And select model again. There we go. And now the Z value is like minus 26.
So what happened if the plane was flipped around? Would you add plus 26?
If you wanted it, if it was placed on the back plane, then yes, you would have said plus 26.
So in this case,
I'm going to show you now because we're going to have to do it with one of the machines.
Okay.
It's very simple. Right. So now that we got our model placed, we can now go and add the machining. So all we need is a drill into that side and then a line cut into this,
Okay.
which is fairly simple to do. So how we do that is select your primary work plane and double click on it.
And double click on it.
Correct.
Okay.
That brings you into the CAM editor. This is where what we use to go and add machining onto parts or machining onto this, for instance. Now you'll see on the left here, you have a front and a back work plane. So on the front work plane, if you looked at your model from the front, that's your front work plane. Back work plane is from the other side. So I know for my hole that goes that way, I need to work from my front work plane. So I'm going to select my front work plane here. And then on the top here is all of your different options that you can use to create machining. So join is to sharp for corners and such. Offset is to offset radiuses. Bend is to bend radiuses. Trim is to delete lines if you added a line. Then here you can add line boring.
Okay.
You can add a hole, a dado cut, a climax connection, a fasten link machining, just a line which is just a cut, arcs, circles, rectangles, and then polygons. So all we need now is a hole. So once we select the hole, you'll see it gives you that little plus that you can place that hole somewhere. Before you do, on the left, you can predefine the settings for the hole. So the diameter is going to be 8 mil, and the depth is going to be 26 mil.
Okay.
Right. Primary, never select primary. I'll show you once we get into the jobs why primary is just, it's specific to certain things. Cool. If you select tool auto select, then screen to machine center will automatically assign the correct tool to the machining. So if it has an 8mm drill, it'll add an 8mm drill. If it doesn't, it'll try and find a router that can do the machining instead. Right.
Which is what we've got in this.
Correct. 8mm is universal. So then I'm just going to place it anywhere on the screen. Just click anywhere on the screen.
Sorry, I made like 5 on
Just right click and
That's
delete
fine.
it.
Yeah, then you can just press escape. Then you'll see you get your mouse pointer back. Okay, did you go out now?
No, I'm back, but those holes are still there, but it's fine.
Right, so select the hole now,
Yeah.
right click and delete it.
That's all there, okay.
Yeah, just delete all of them, keep one.
Is there no way you can drop and drag and pull it?
That's what we're going to do now.
There's one in
But you don't need 5, you just need 1.
you know.
Okay.
Okay, you've got 1. Then if you select that hole,
Okay, these get filled it right.
then if you select it, you'll see there comes a little square up in the middle that you can press on. That snaps to your mouse.
Okay.
And then you can drag it and drop it where you want. So once you place it over that circle hole there, it should in theory snap. Does it snap automatically?
No, mine's not moving.
You made one on top of each other, so you
Yeah.
just go back.
Something good.
I think it's very true. Actually,
When I was trying to move it,
yeah, funny if it don't open.
Now, if you select it like this, you can drag and drop it. Now, if it doesn't automatically snap, which it should, it's the option here, snap to bits. Then you can just select it, drag it, and it snaps.
So is that the same thing for your cabinets?
On this. But for this, if you want to use it in your job, on your
So
parts
the
and
snap
such,
function is never not always.
no, the snaps is everywhere. The snap function
it?
is everywhere. But the XDCAD to add these holes and such, it's only available in your jobs if you have the XDCAD module. All right, once that hole has been placed, we can just go back quickly.
okay. We go back.
You just press return. Then you'll see it won't look like there's anything. But on the left here, there's a front hole. You'll see it's right there. There's your machining fork and everything. It just mirrors what is there. So the only thing that we need to do here now is just make sure that its Y value has an equation. So for that, on the Y value, see there it says minus 9.4. That needs an equation. So there, I'm going to add the same equation as what I did on my model. So I can go back to my model here, go into my Y equation. I can just make a copy of that.
So go back to model. So from front hole, go back. Okay.
Yeah. Make a copy of the Y value equation that we wrote. The minus dy divided by 2.
Okay.
You got it. Then I can go back to the front hole, into the Y, and just paste it there.
So we paste it into the bin. Okay.
And now it's not working. Why is this not working now? No, that's why. We need the dx value. I forgot this one was made a bit weird enough. So instead of saying dy, it needs to say dx. So minus dx divided by 2. Place it there. This is now not. Different equation for this one, just write it down. I forgot they do it differently now on 2024 than what they did on 2023.
Okay.
So there you need minus
So this is now for the hole.
On the Y value, yes. The nice thing is if you want to do it again in the future, just come and check on a previously created one also what was done.
Okay.
So it's minus double point
Okay.
EZ
Mhm.
/2. So what that does is it tells it that double point
Yeah.
in the equation rule of cabinet division, the double point means parents.
It means
Parents.
parent.
Yeah. So everything in cabinet division works as parent-child relationship.
Oh, parent. Okay.
Yes. So front hall, if I say one double point, it means parent. Then it looks towards the primary work plane. If I say two double points, it means parent's parent, which means then the shelf. And the DZ is the thickness. So it looks then towards the thickness of the shelf divided by 2. And that's what it minuses down towards, and then it sets it dead center.
Yeah.
And it's a bit confusing. I'm going to show you guys a shortcut in the help file that'll give you just a bit of extra information about the equations and such. Don't stress too much about the equations right now. It's not something you're really going to be using right now. These are just the basic ones that gets used over and over and over and over again with the connector.
Yeah.
And the nice thing is you don't even need to learn them. Just go back into a previously created connector and just copy and paste. Right. So now that we got our hole into the side, we need our groove still for that. And that we're going to be doing exactly the same way. So I'm going to select my primary work plane, double click on it.
Okay.
And then I'm going to go to my back work plane.
Okay.
Then here, I'm going to select on the top here, line.
Mm-hmm.
And then my depth, I'm going to make, what did we say was the depth in that?
7.
7. Yes, 7.
Was it? It's not 9, and the cutter was 7.
Let me check. It's easy to check quickly. Let me just check first quickly. So it is 8.5 mil deep and 9.4 mil wide.
.5 deep
And 9.4 mil wide. Right. So with the line, I'm going to say the depth is 8.5. And then here on the cut, I'm going to say center. And on tool. Now here we're going to go and assign that tool that's meant for this manually once I've set all of that up.
Sorry, 1 second, DJ. My depth, when I'm setting it, it's not allowing me the points.
Try comma.
Okay. Right. Then cut the center.
Center.
Okay.
And then on tool, you'll see it says the auto select. So what we're going to do here is I'm going to force this cut to use the specific tool meant for it. And I'll do that once we got your machines and everything set up. Then I'll just come back to it and change that. But for now, I'm also just going to leave it on auto select. And I'm just going to add a line. So you'll see if you hold it here, it snaps automatically to the center.
So if I click anywhere on the left.
Now just hover it over it. You'll see it snaps to the center.
Okay.
Press it from the left, straight through to the right.
Right. Yeah.
All right. And then that's it. The width won't matter because the width will come from the tool.
Okay.
Right. And let me just check. That should then be fine. N1 length, depth, index Y. Okay, looks good. Right. Then you'll see now if you go back to your view mode, to your front view mode, there sits your cut there. And the only thing we need to do now again is actually we don't need to do anything there because that equation won't. I don't think it'll matter.
I have to go back to the view. So,
All right. And then all I do there is I go back to my front hall. I go and copy the equation that I took for the y. and I just go and paste it in the Y for that cut. So from the Y value here, I copy that,
Okay.
and then in my back line, the one that I just created, I go back to the Y for head, and then just paste it.
For the Y.
Correct. And there's your connector model. With its machining added, everything. The only thing that will change now with this, once we get your machines and everything set up, is I'll add the tool for it manually to that so that it gets the correct width and count and everything.
So we'll do the test, make sure we're fitting it.
Correct. We'll do all of that once we do the machine integration and the
Because it has
setup.
like an offset and
Yeah, no, but
yeah.
that we set up all with the tools.
with the tools.
Right.
Oh, that's a big help.
So that's how you set up a model. It's not too intricate. It's just those equations that can get a little bit tricky. But the equations that we used here will be used on every single other model that you bring in for your connectors. So copy and paste. That's all you need to do. All right. Now that we got our model, we can go and set up our connectors, our connections. So I'm just going to return. Save changes. Yes. Then we can now close all of this. Right, come back to the splash screen.
Okay.
And then we can go here into connections.
Okay.
And we're going to go ahead and say new.
Okay.
And name, we can just call the OVO RD12. And then by type, there's going to be boring, connector, dado, dovetail, adjoint, line, ball, mortise, tenon, and set. So we brought in a connector model. So we're going to select connector. We're going to say next. Here it's going to prompt us to select that connector material. So if you press there on the three little dots, it's going to open up your material manager. And then we can just go under our connectors under hardware and just go and find the newly created one.
Okay.
And then double click on that.
Yeah.
Let me say next. Now here, specify the edge position of your connector, center on thickness or table bed to wall center. Normally it's just left on center on thickness. The only time I'll do table bed to wall center is if you use like a raft or a minifix or something. It needs to be a specific height from the edge of the board. But for this, center on thickness, next. Specify the position of the connector for mitered parts. Center joint, that's fine. Next. Do you use a fixed head horizontal boring machine? No. Next. Now here, specify how you position your connectors. There's a few options here. You can say front and rear connectors, run front to rear, run rear to front, or balanced. So front and rear connectors, you tell it, okay, you want 1 or 2 or 3 or 4 connectors in the front of the part and 2 in the back of the part. That far away from the edge with spacing of that much between them.
Okay.
Which we're going to be doing for these.
So it'll repeat and you specify the quantity.
Correct. So run front to rear is we're going to start it, okay, this much space and this much space from the front and this much space between every connector, and it's just going to run a line of connectors through them. Same for the run from rear to front, but it's going to start from the back and run it. And then balanced is you give it a value from the starting point of the front, starting point of the back, as well as a minimum gap width between them. And it's just going to put a balanced amount of connectors in the middle. But with stuff like this, how do you do it? You maybe do what? One on each side.
I think on like a 600 floor unit, it would be 3.
Okay, so if it goes over, let's say 600, then you get another one in the center.
Probably.
Right. For that,
Okay.
Let's see what you put here.
Okay.
so for that, we're going to use front and rear connectors. So I'm going to say next there. Then it's going to ask me, okay, specify the number of front connectors. 1. Okay. I say next. Specify the position. Sorry, of the position of the first connector or the minimum distance. So from the center of that hole to the edge, how far is that?
I'm not sure.
Just make it 50 for the test.
So just 50. And we can say next. Now same for the back. We can say that again 1 and 50. So position number of connectors 1, position 50. And then here, specify the maximum space between the series of front and back connectors before adding additional connectors. So if you say, let's say if your unit or the part stretches above, the space between the two connectors is 600, it's automatically going to add another one. If that space is again 600, it's going to add another one. So what would you say is the minimum space there?
So what? Okay, answer the question. 7 using 560 cameras.
Yeah, but that's up to you. What would you say is the maximum distance between those connectors before adding another one in the center?
Half.
Half. Yeah, but
Yeah.
What would the number be?
yes.
We said 560 minus 50 is 510. 510 divided by 2 is 245.
So let's put it on 300, just to give you an example. Right.
Okay.
And that's it. That's your connector setup, your connection.
Okay, yeah.
So I'm going to say OK. And there you have your over RD12. Right. So what I want to show you quickly, I just want to show you how that connector now comes out. You don't have to do this now. I'll just show you quickly.
Are you working with this now?
About 2 years.
Okay. Still learning or you after the
There's every day something new to learn. It never stops. 12. So there's your connectors. Adds one in the back, 50 mil from the edge of the part to the center. One in the front, 50 mil from the edge of the center. And then it gets another one in the middle because the space between those two connectors are more than 200, more than 300. But if I now go and I'm going to change my depth to 300 per se, it's automatically going to take that one out, leaving you with just the two. Right. So that's pretty much how you do it. So now, even if I now go and make the depth again 450, it adds another one for me. And if I go and make this depth 700, okay, so space between them is still less than 300. Let's make this 900. And they automatically get another one. So it's whole center to whole center, 250, 250, 250. Makes sense. And if the connections like this are red, it means everything is fine. It means there's no issues. Machining is going to be drilled and everything. But if this connector is grayed out, so for instance, if I go here and I go and tell my floor bottom, my width, my length, let's say minus 5. See what happened then? My parts went into gray because there's a gap. The connection isn't touching the next part. So if something like that happens, the gap can be a millimeter. If the connection isn't set up for that millimeter variance, it will not fire. The parts need to connect. Otherwise, the connection won't fire. Right. But
Zoom into the camera again if you don't mind. As soon as you're complete. No, you're zooming out, zooming. And where's the default for this?
now that gets done when we run
Only when you run
screen to
the
machines.
screen to
Yes.
machine, okay.
Now that only gets done once the post reads and it outputs to the machines. All right. So that connection looks good.
Because of the time constraints of we were anticipating it to be smoother, but there's a lot of things that happen in between. starts working. Customers instantly can
I know.
orders to be cut and processed. So given all of that, we still managed to do a few smaller ones.
Alright.
And I think the beauty of it now that you're giving us your invaluable inputs to this, we're just going to get so much more efficient.
Oh yeah, definitely.
And there was a few bugs that we had to fix up. But I'm just saying, given what we had to work with, we managed to put, and I think now we've got the next one.
Yes.
We're ready for.
Yeah. So if the machines are set up correctly and all the tools are there and everything, we set all of that up in Cabinet Vision. I'm just going to show you quickly. We set all of the tools up for that specific machine. We set the machine up specifically according to that machine specifications with the post and the link and everything. And then once you're done with your job, yeah, it's going to take a while because screen to machine is quite slow in this version. Once you're done with your design and you're done with everything, you go to screen to machine center. It breaks down your cabinets to the parts. You press on your machine, you say optimize. It runs your optimization for you, and then you run NC code and labels and it writes your G code. That G code you just plug into the machine reads the G code, and it does the manufacturing. You don't have to go and manually input anything on the machine anymore and draw on the machine.
Barcode scanner, is that?
We do barcodes on the labels as well. So if you do, let's say, a beam saw and a drilling machine, a point to point, all of your parts gets cut out on the beam saw, and they get a label. Stick the label on the part. You take the label to the part to the point to point. They scan the label. They get their run code. Put in the part. Run the G code.
I would assume we've configured this for a KDT machine.
Not with a KDT as of yet, but we have done it with a few other machines.
And so
the process is the same. It's just a label that scans. If you have a label scanner that's linked to your machine that can bring out the run code from the label, you put in your G codes, your whole list of G codes for that. Let's say it's a.
Crystal was also saying that you can use it as a scanning to production, meaning that it will scan the missing pieces that will tell you which is complete or incomplete.
No, that's something completely different. That's CapSync. That's a production tracking software. It tracks where your parts are, how far they completed manufacturing the parts, if it's been assembled, if it's out for delivery.
When you come to the factory, you're going to tell us you need it.
Most people need it. It's in cabinet vision.
Yes, it's got the scanning function before you get to the factory CapSync scenario. Because it wasn't very expensive. It was not expensive
Oh, that's the paper trail thing for cabinet vision as well. Yes, that's the one for another one that's also built for cabinet vision. Labels we do from cabinet vision as well.
The beam saw
for beam saw for nesting such as. You can either use if your beam saw has an integrated label printer, we can set it up with that, or we can try. It just depends on the machine and if we can, because we have done it with a few. And then otherwise, what a lot of people do with their nesting machines is they take an old laptop, we install the plus label software on it. It's small. You don't need a heavy machine for it. Plus label. It comes with screen to machine. You can buy it as an add-on for screen to machine. And then you get a little label printer. And then as you're cutting your parts out, it'll give you a display of your sheet that's busy cutting. And you press on the part, or you just click on the part that you want the label. It prints the label and you stick it.
Can I see that data you were talking about?
Yeah, let me show you. Let me show you quickly. I have a construction method using it. The data are incredible, and it's a tight connection. It's beautiful. It's a beautiful fit.
It's allowing you to you got to almost assemble it.
But the manufacturing time
method and so on.
You can do it however you want. You can do it with screws. You can do it just with glue. There's a lot of ways that some people just do nails.
Because we're looking at speed and time and
yes,
accuracy, and we thought that this system worked the best for us.
So you'll get your little part. Let's take the top cleat as an instance. I'm just going to go there to plan view. Let's go to you'll get your top cleat, your top stretcher. It cuts out a little lip of your design. You can say 8 mm, 7 mm, or however. And then into the side of where that part slides into, it cuts a little groove. So that just slots into it.
So it's like a mortise and tenon.
It's like a mortise and tenon.
So you're cutting like an L,
You're not even out.
No,
It's
it's
if you have, let's take this one for instance.
basically a mortise and finish.
Yeah.
That's a mortise and finish.
If you want to connect this like that,
Yeah.
here it'll cut that off, leaving you a little lip there.
Yeah.
Let's say it's 8 mil deep and that little lip is 8 mil wide. Then it'll cut you a little 8 mil slot there. That just slots into it.
Yeah. So in my mind, it looks like a panel.
Oh yeah.
Okay, so then, okay, I hear what you're going with that because that's for
How deep do they go?
Half of the board.
that is the whole method.
But it works. And it's a beautiful it's a beautiful fit and finish. It works a lot like these connectors. But the nice thing about the data as well is you can leave a little variance, like a 0.2 mil variance. So if it doesn't, let's say for instance
You can line it up to
your data sits like this, you can still line it up perfectly and then leave it to sit. Or you can line it up perfectly and knock it with a nail or a screw.
Yeah, but that's what we're trying to avoid. Nobody, that's what I'm trying to
We're trying to avoid. We want two free assembly.
when you say everybody is using it, I get to differ on that because what works for others is not working for others.
No, I'm not going to say it's going to work.
Why people are doing that deliberately.
We have a lot of clients that's running with this. But it's
And you really can.
some of them glue and clamp, others line it up and put 2 screws in.
Are you guys doing with the future classes?
I don't know who knows.
Okay.
But it's to each their own.
So do you have this come out, or can you load us one and we can go as well?
I can show you how it works,
Okay.
and then you can set it up and test it. But
You
this
know,
isn't.
You know what we can do, and I think it's nice that you shared this with us. If you don't mind, I think when we get to the factory, you can share these files, and we can see the 3 different formats. And I think it's always nice to show it to our clients as opposed to saying, no.
Yes,
And
definitely.
our machine has got the capacity
Yes.
to do that. And I think that's if we get a shop putting project where the guys are busy with solid walnut or wood or whatever it is, and they want this finish. You can have it.
Yeah, because the nice thing about the
Get
data.
away from the fact that no one wants to use glue and clamps and screws.
No, I understand that.
That's really good.
The nice thing about the data as well is if you do something like this and you cut it on the nesting machine, this needs to go to a secondary machine for the drill.
That's all.
So most people who are doing data are using nesting.
Are using running
So
netting
most people that
machines,
are running 6-sided are doing Canon.
are doing cam and dowel or
Okay, then it makes
connections
sense
like
because
this.
you're limited with vertical drilling.
Yes,
or
and it's
horizontal.
fast.
Yeah. So that's why Pascal is doing it because he's got 2 CNC nesting machines.
Now you cut all of it once off on the nesting machine.
He's got XYZ doing.
On the nestings,
Yeah.
he has a point-to-point for that,
Okay.
as far as I know. A skipper or something.
Well, I mean, the fact that you've configured the configuration is fine. So if you share the BXF format, and you can just pull it through and you can see what.
Yeah, we can see that once the machine has been
And,
set
things
up and
connected, yeah.
everything's up and running. Right. So we set up our connection now. I'm not going to set this up now for the cleats, your 100 mil cleats or such, because I don't think you're going to be using this for it. You're going to use it. Do you just add 1 or do you still add 2?
Let's add 2.
2 for now. Okay, then we're going to create another connection for the cleats specifically just to space them a little bit better. So nice thing about that is we don't have to create a brand new one. I'm going to go to my connection manager, scroll down to your over RD12 that we created, right click on it, or just select it and there on the top say copy. And then that one, we're going to just say over RD12, rails or cleats.
And which other methods have you found? So that's the only one that you've worked besides all the other ones that you've imported.
Now we've worked with a lot of different connections. A lot.
Are there any dovetail or previously?
We have one client who did a dovetail a while ago, but otherwise, no.
Is dovetail on this?
You can set up a dovetail connection as well. Right. So then I can just double click there on the ID to go into the connection. Connector is going to be the same. I'm just going to say next, center on thickness, center joint, Horizontal mooring machine, no. Now here, front and rear connectors again, yes. Now the number, I want one connector in the front, and then we can maybe just limit the space a little bit to move it a bit more to the side. So from the side to the center of the hole, how far do you think?
30 or
Well, we use the 100 meter arc because there's a little again. No, you do two on the one last two.
yeah.
So you'll always be cognizant of because you're using this fitting that's 30 apart. So you do middle of that.
It's 15, so you can maybe say 10 from the edge, so 25.
25, yeah.
This is that's 30.
So the number will be 2.
No, 1 from the front, 25 from this 25 spacing,
25, okay.
and then next, 1 in the back,
Okay.
and then spacing there also, 25. And then here by max spacing, you can just make it 0 because you're never going to have another one on this connection. And then we can say, okay, save changes, yes, and that's it. That's your connectors set up. Right, now we can go and create our construction method using these connectors.
Sorry, is this the construction method for the cabinet?
Yes, we're going to set up the construction method for the
So
cabinet.
if we want to add one more to complete the construction method, we still can.
One more connection.
Yeah.
Yeah, you can modify the connections however you want.
Okay. So it's a different connector that slides the solid wrapping in.
Yeah, so if you want to create that connector as well, you just create the connection. Remember, we just created the connections now. We haven't assigned it to anything yet. We only assign it once we get to the assembly manager, where we set up our construction.
We will be using it.
Yes, and that's what we're going to be doing now.
This is like the back end.
Yeah, if this is set up, this is my least favorite part of cabinet vision. It's dreary. It's easy. It's incredibly easy. It's like writing an exam.
Yeah.
But the nice thing is, if it's set up once correctly, you will never touch this again. You just select it when you start your job, and you know your construction will be correct. It's going to take some time to fine tweak it where it needs to be correct perfectly for you. But if something changes, you just can just go into it again, go and find the specific place and just modify it. Right. To create a new construction method, you'll see there is a few there already. So you'll see there's on the top drop down, there's assembly and draw box and roll up. So assembly is for your constructions, for your units, all your units from base straight through door units, corner units, wall units, all of them. Your draw boxes is for your draw box construction method. Now this will all be set up already for the runners and such that's pre-set up in Cabinet Vision. In the event that you guys want to bring in new runners or such by yourself, then we'll show you how to do that in detail. Right, so I'm just going to select assembly. We don't have to worry about the ones that's already there. We can just go ahead and say here, new. On the first one, it's always better to just create a new one, because then you can actually set it correctly. But luckily with you, because you have just 2 standard connectors, it's actually going to be a lot easier for now, because once you get your other different connector set up and everything, you can just modify it as you need to. So for the name, we can just call this Unipanel Standard.
Okay.
Right. So under style on the drop down there, you'll see you get a 32mm face frame, frame overlay, and frameless.
Okay.
So 32mm is usually 32mm BIC constructions. That's a specific construction method for those specific units. Face frame and frame overlay is the American style of the face frame constructions. Frameless is the standard, what we use in South Africa. So we can just select that frameless. Now you'll see, because we selected frameless, the frame will be blanked out. I can't do anything there.
Okay.
Now here, it's going to assign those connections in bulk. But we're still going to have to go through it and just assign everything to how it should be correct. So on adjustable shelf, what connection do you, how do you guys do your adjustable shelf holes? Shelf studs. And spacing? 32 more. So 3 holes, 32 apart. Right. So what we can do for now is I'll show you how to modify it, but we can just take the adjustable shelf pin, 3 holes.
3 by 50.
No, just adjustable ADJ shelf bin 3 holes.
Mm-hmm.
Scroll up to the top. It's the fourth from the top.
What did you say then?
My fourth one says clip that line.
Okay, so you don't have
I
that.
only have ADJ, shelf hole, 3 by 50.
We can just run with the 3 by 50 for now. It's fine. You're gonna have all those other ones once I give you all the database backing. So unfinished back. So that's your 4mm masonite backing. Do you guys use a 4mm masonite back, or do you normally just build the 16mm solid back?
Both options.
Both options. Okay. Luckily for you, we do have the unfinished back is for your 4mm, and then your finished back is for your 16mm, your solid backs.
Let's start with a complicated one. The solid one is quite easy. Let's use the one where we're using a semi-solid masonite because you got the two back fixing rails.
Yes.
And then you got the
Right.
groove. So,
So-
choose that one, right?
Yeah. Now, unfinished back is going to be automatically masonite.
And does it pull in the back fixing rails again?
We're going to set all of that up now with the construction method.
So run that.
But
run the
what
first
connection do you do for your masonite backing? Do you slot it in with a groove or
With the group. Yeah.
with a groove? Right. So you'll see there should be a backing groove connection. That is set up using a data connection style. It just slots a groove through the thickness of the masonite back. Right. So we can just select that there. For interior case, we can now just go and look for the OVO RD12. We can just select that there. Exterior case, OVO RD12. There we go. And then for your toe kick, do you guys build with toe kicks? Or how do you connect them?
Well, for this purpose, this is use the adjustable legs.
Just adjustable legs.
For
Okay.
now.
So then on your toe, we're not going to add any connections for now.
If we had to, what's the common option?
Dowels, screws, nails, just something simple and basic because it's not really a connection that you're going to be seeing. So most people just either nail them together or dowel them together or such. Right. So, but for now, we can just leave it on that. And I'm going to say, okay.
Let's just, okay, all right, you went out. Fine. Okay.
What everyone else? You can go back to it.
Yeah, no, I'm saying, but okay, pass on it. It's okay.
So it's going to take a few seconds, but then you'll see it'll create your new construction method for you here now. It'll say there on top, unit panel standard. Got it. Got it. All right. So now comes the fun part. Now we're going to have to go through every single part, tell it what edging it gets, how it fits, where it connects, how it connects with every other part.
Okay.
So we're going to start here with interior case, adjustable shelf. So you can double click there on the adjustable shelf, and then starts the exam. So it's going to ask you here on top the question, and then on the bottom you just fill in what you think fits best. So define banding for adjustable shelf. So on your adjustable shelves, you just get banding on the front, or do you put edging on the sides as well?
For this purpose, do it all down.
All right. So then on face, now you see there when I told you about the exterior and interior edging.
Mm-hmm.
So we know exterior edging is set for exterior color and interior edging is set for white color. What edging do you normally put in your adjustable shelves to fit the outside or to fit the inside? Fit the outside. Then we can say the exterior edging.
Yeah, I see where this is going. That's good, yeah. No, if you're doing components and you're doing edge one along with the matching color, you're doing three sides with a different edging, the parameters are already in.
Because you can specify here. So
So that's what I'm saying. It's again, instead of you recapturing that day, it's already done.
Yeah.
So
No,
no, I love it when people act like this.
because the file format that we're going to have basically is going to be inputted into our software. So all we need to do is select, and it's either choosing three sides plus one finished matching side, or if they're wasting money off, you're doing a match complete match. Listen, like I said, at the end of the day, we don't have advance, we will need to do it.
You have to do.
But we have to do it in such a way that it doesn't use a lot of admin work from our side. That's the only problem.
Now, cabinet vision does tend to make you a little bit lazy in the admin department because it does a lot of the admin for you. Right, so yeah, here you can say on the face, so that's the front edge. We want exterior edging. On the back, that's on the back edge. We can also say exterior edging. and then the end is the two sides.
Yeah.
So we can just add exterior edging to all three. Then we can say next. Define banding for shelf bull nose. Now, shelf bull nose is that little lip that you add on the front. Now, the only times you will actually add that is if you do it for a job specifically. But then you can rather go and modify the construction method for that job specifically.
The job windows is like a rail attached to the shop.
Yeah, it's like a 16mm rail attached to the front of the shelf,
Okay.
a little stopper. But if it's not something that gets used overall on every single job, so we normally just skip that over. So we can just say that.
Doesn't that mainly happen on the shelf that's at an angle?
Correct, for your wine racks or your shoe racks or something.
Right.
Yes.
Right. Okay. So this one we would just say next.
Just say next.
Okay.
Then here, if your adjustable shelf uses material with grain, do you align the grain with the cabinet width? Yes or no?
Yeah, you do
Yeah.
that because if you're doing it as vertical,
Correct.
the bottom shelf will go with the grain. So,
Yeah.
well, it gives you the options of both.
So you
If
can either say
do
the yes.
normal, then you will turn the shelf the other way.
Correct.
That will be on the optimization. It's asking you to prepare for the heating of course. So in this case, you flow unit you want to flow.
Yeah, so yes. So we can say there yes, and we can say next. Specify the distance between the adjustable shelf and the face. So do you guys recess your adjustable shelves back? By how much?
So 20.
20. And you can just add that 20 there, and it'll always just recess your adjustable shelves for you. You can say next.
Corner.
If your adjustable shelf uses material with the grain, do you align the grain with the opening? So some people do it, yes, where they then cuts out that wonky part with the grain running down that way. Normally it's just, just keep it running one
Yeah,
direction.
because if you cut it from a cross corner, it wastes a
It's a lot of material.
It will take that 1 square meter and turn it becomes the whole board.
The next, select shelf nosing option for adjustable shelf. So shelf nosing is like a little groove into the shelf for grooving or such. This isn't really something that we do much.
Go back on it, let me just see. Oh, okay.
So here we can just say no
So
shelf
then
nose.
rebasing.
And then we can say, okay, that's adjustable shelf done. Now we can go to divider.
Okay, so you just specify each one.
Well, it's architectural.
Like I said, it's like an exam. It's dreadful, but once it's set up correctly, you'll never have to do it anymore.
So can I ask you,
Hmm.
you did this whole training with Zayed at one lab?
I think so, yes.
Yeah, I think it's a sort of like it.
Yeah, I don't know what the issue is. Because we never used it.
You went to take it and you do the training.
No, I think it was online.
No, that was online.
Online, yeah.
Yes. The thing is, over time, that we do the training a lot different now. So where then we would do the 3 days training like 1 block 2, and then the training's done. And we realized it's too much because it's way too much information to pull in. So how we rather do it now a day a week, and after that day training, we give you the little test. You complete the test. Once the test is done and you guys are happy, then only we move on to day 2. Plus, I now give the screen grab videos and everything as well. Right. So define banding for divider. So divider is normally locked on the bottom, back, and top, so it's just going to be face edging. So then on the face, we can just say exterior edging. You guys also edge it to match the exterior. So face exterior, next. Select the grain direction that is most commonly used. It's going to be vertical grain most likely.
Yeah, because you're using vertical inside.
Correct. So next. Now here, which face do you want the machining on a divider? So this is if you use like a Rafix or a Minifix or such, or even if you do data connections.
And you use dowel,
Dowels, no, because dowels is dead center. This is only if you need to access the connection from the side.
Yeah.
So for your Rafix or Minifix, then you can say open it to the left or to the right.
Oh, okay. So in this case, if you're using a cam and dowel, you've got to use this option.
Yes. But with you guys, it's a hidden connection, so you don't need to worry about that. And we can just say, okay. Then we can go to drawer stretcher. Define banding for drawer stretcher. Do you guys build with drawer stretchers?
Yeah.
What's the force switch?
So you're doing bigger cabinets, and sometimes you want to do an English kitchen, which you're going to do shaker doors and stuff. So that is a preventative measure for the drawers to bow. It will be an overlay or underlay. No, it's actually basically what it does. Good question that you asked. You know the big carcasses you're busy making. Sometimes the carcasses go upwards. The stretcher pulls it back in. So you've got multiple drawers, It also defines that look because you can bring the drawer fronts inset as well.
Is there a stretcher there underneath that?
Yes, in this cabinet where you have the stretcher, that's a stretcher.
That's a stretcher.
Yeah, that prevents the carpet from blowing out. Otherwise, you see the little shelf in it.
Yeah, that's a stretcher.
So basically,
That's
somebody
the stretcher.
Like a three-port drawer, such with heavy weights, it
It
squishes
pulls
it
the
and
solid
and then
thing.
bows it aside. Yes. So
So
you add.
these are things that actually, these are things that actually, because sometimes you go to a site and you say, what's going on here? What is happening? In the meanwhile, the stretcher is important. Sometimes you can hide it underneath the drawer, so you don't know the stretcher.
So it's a structural integrity.
The structural integrity, yes. Especially if you do like pot drawers or such that takes heavy load bearing on the drawers.
Because at sites can only take that much. That's
So with this, you'll most likely just edge it on the front.
yeah. Well, if you've got, for example, an island, we'll put two.
Yeah, but on the stretcher itself, it'll just get edged on the front of the stretcher.
No, sometimes you do both. Because your client puts an island because it's such a small piece, and they feel that the one is in resend it.
Okay, yeah, that's true. Okay, so we can then just say the face exterior.
Cost you. You can imagine that.
That's good
We
to know.
waste money. The quality is unsurpassed.
No, that's good. So exterior edging on both. Next. All right, so select the option which best depicts your construction method. Top drawer stretcher, top and mid, or no drawer stretcher. So for now, we can just set it top drawer stretcher.
You can add one on each one.
Correct. Or you can say top and mid. So then it'll add one below each drawer, but we can just add one for the top for now. If you do need it more, you can actually go and manually add it as well. Or if you know you're going to do a job with a lot of drawers that's going to be needing this, you can just set it top and mid drawer stretcher, and you can just go and
It doesn't allow you for all drawers. Does allow you that option?
yeah, that's top and mid drawer stretcher.
Yeah.
That then adds it.
Right.
Then it adds it for all.
Can you change the stretcher dimension?
Yeah, we're going to do that now.
Oh, okay.
So once you say then here next, it's going to ask you enter the width of your drawer stretcher. So that will be what, 80, 100.
Generally, make it 100 under the purpose of the training.
We can just set that to 100, and we can say next. Which face do you want the machining on a drawer stretcher? So that will always most likely be what?
Yeah, from underneath.
Correct. The only time this will be from top is if it's a dado, because then the dado lip needs to sit there, not on the top.
Now, sometimes you can use that when you're busy with the oven unit, that the cam connectors are seen in the open space from underneath, but if you're chairing a shelf, you don't see it from the top, you see it from underneath.
The nice thing also is you can set this as a set standard that most of your units use, but if you do have that one specific unit that needs it to flip, you can flip it on just that unit itself. And then can't say next anymore, so we can say okay.
I'm gonna want to send the master kitchen visit.
I just want to take this problem.
Must get cold on you guys in Albert.
You don't want to
Yeah.
know.
Especially mornings and evenings. Eh?
Because we're sitting in that lacquer
Yeah.
dip there by us. I was standing, when was it? Last week, Thursday. I was standing outside, couldn't sleep, so I was standing outside just having a smoke. I think it was about 12:30.
Yeah.
-1.
And it's not even peak winter.
And it's still autumn.
Yeah.
No, it gets flipping cold and
But
hard.
I'm not saying the cold is a bit early this year.
We're going to have a freezing winter this year.
Yeah.
But it's because of all this rain we've had.
But I like the cold. Eh?
No, I'm also a winter person.
I prefer the cold anytime.
No, I don't like sweating. I don't like heat.
Yeah.
I am a winter person through and
Any
through.
excuse to make a fire outside.
Now, my happiest time is if it's winter, I get my fluffy socks, my comfy parka jacket, and I can sit in front of a fire with a book. Then I'm happy. Can't do that in the summer though, you'll die.
Very much.
You must have seasons, though.
Yeah, you do need seasons. Right, so you can go to fixed shelf now. So fixed shelf, you guys will see there's three different shelves. You get your adjustable shelf, a fixed shelf, and a shelf.
You get three different types. You can just
Shelves.
Yeah.
So adjustable
Okay,
shelf
yeah.
is a normal adjustable shelf.
What we did.
A fixed shelf is a normal fixed lock shelf,
Good.
and then you get a shelf.
Right.
So the shelf is there for all of the customized stuff.
Right.
So let's say you have a grocery unit that has two adjustable shelves at the bottom, two fixed shelves in the top, but then you need small little shelves in the
In
center that
between.
rebates to the back, and it's just a whole customized thing, which you can't use the fixed shelves and the adjustable shelves to modify for because they're already being used. Then you use the shelf. So that's for all of the customized items and such. So we normally set it up from the get-go as a normal fixed shelf, and then we modify it in the job as we need. Right.
Or do you have being fixed and then you have the adjustables in between the fixed? Can you do that?
Yep. You
Oh,
can
okay.
add
You can do,
shelves.
you can do anything
You
basically.
can do pretty much anything with cabinet vision with the customization. So define banding for fixed shelves. So fixed shelves will just have banding on the front because it's going to be locked all around. So we can say they face exterior. We can say next. Define banding for shelf cool nose.
Yeah, for the purpose of the training. We just want to see what this is going to do when
Right. Yeah. Remember, if you put all around edging on the
fixed shelf.
fixed shelf,
Yeah,
you
yeah.
have connections on the side.
So they can understand.
Oh, okay.
It's going to cause problems with the connections
Sam?
because they're going to pick up. Okay, there's edging.
Yeah.
It's going to push the part away from the shelf.
Yeah.
The machining there isn't going to fight.
So, okay, let's take it out.
Now you need to be very specific with it. Exactly how it will be in real life. You need to set it up.
Maybe I also want to make a note of that. So this is kind of Some do you think you would need that
For the machines,
Yeah.
I'm not sure.
Okay.
Chris will give you a better variance of that. I mean, I integrate all of the machines, but I can't give you a solid time. Okay, I'm going to be done by here. By here, we'll only actually know that once we get the specifications of the machines plus the sample run files, because then I can go and compare with what we have and work out a timetable of how long it will take to.
Sorry, Robert. It's just Bloom to see that back one so they can.
Oh, that's fine. Right. So next question. Patience is my middle name.
So Francisco called it.
Now we'll get done in time at least. We're gonna have to run it a little bit through with the doors,
Right.
but the doors are incredibly easy. They are
Okay.
super easy. And I'm actually thinking I'm not gonna stretch you guys out too much about the wrap doors and such today, because the tool sets and everything isn't going to be able to be set up yet. So we're not going to be able to test and check and show you how it works exactly. So I'm going to show you how to set up the door itself. But for the root path profiles and such, we can cover that when we get your machines up and running, because then we do screen to machine training as well. Then I'd rather show you in detail how to do that.
So what DJ is saying for fixed shelf,
Yeah.
you limit it to edging just on the side.
Yeah. Because it's fixed, it's taken, it knows that it's
You've got
tight.
pieces and stuff.
No, it knows it. You're connecting it on the other side.
And the problem is if you add edging onto the sides of that fixed shelf, because there's connections there, that edging is going to push the part away from the part from the side. So that machining's not going to fight. It's going to gray out the connections like I showed you guys.
Because it not take the thickness of the edging into
It does, but the part itself needs to connect to that part. That edging.
It doesn't recognize it.
It won't machine through the edging.
Oh, okay, so they said they define that. Okay.
Now that's why with this you need to be direct with it what you want, because what you put in here is what you're going to get.
So this, okay, so let's move past it. It's fine.
So next is your fixed shelf. You use material with grain. You line the
So
grain
the,
with the
the
cabinet.
bonus you said no.
Yeah, no.
Okay.
So that's with yes, because it's all going to be vertical. Next, fixed shelf use material with grain. You line the grain with the opening. No. Select shelf nosing option for fixed shelf. No shelf nosing. And then which face do you want the machining on a fixed shelf? That's always going to be bottom if you do use it. And then we can say okay.
Unless you specify other parameters.
Yes. Then we can go to nailer. So nailer is your back nailers. So yeah, define banding for nailer top and bottom edging.
Yeah, well, again, we try to show better quality, so we'll do edge one now. So again, you just choose this and edit it.
So edging top.
Yeah.
So exterior edging,
No, it will be bottom edge.
bottom edge.
Yeah.
Right. Oh yeah, because the top's going to be against the top, the countertop. Okay. Next, define banding for nailer mid, top and bottom.
Yeah. Let's see, it's very.
And then define banding for nailer bottom. That's going to be top. Question. You don't use the back nailers for your wall shelves, your wall units.
You know what? That actually also acts if you got a stretcher. That also becomes a stretcher for the back. That's another predictor. So if we're doing larger cabins, we've got the 3 stretching bands in the floor unit, then you just add one in the middle. You don't need to add 3 each floors. But some here you need because it's structural. All right, got you. Anyway, so you got many things.
Yeah.
Well, you can turn it on or off in any way.
Correct. Okay, we can go next. So if you construct with the top nailer, into the width of the nailer.
You just use 100. Yeah, just use 100.
Next, where do you attach the top nailer? You can specify an adjustment if needed. Does it go inside the back, outside the back, or do you not just
Inside.
So inside the back?
Or the other way around? That way, yeah.
All right. You can just leave it outside the back, and you just leave it flush with the back.
Yeah, because I think you've put the parameters that almost it must have crushed.
All right. Yeah, because here you can actually push it in so that your side pieces push past it. So you can put like a 10 mil variant. So if your side panel sits here, your nailer will sit in there instead of flush. You can actually push that automatically back as well. But we can just leave that on zero. Next, if you're using mid nailer on a cabinet over a specific height, you can specify the minimum height below. So if your cabinet reaches a certain height, how high would that be before it adds a middle? Yeah, but how high? What's the height of the cabinet?
Or the distance in between them, is that basically what you're asking?
Yes.
Keep them in increments of about. Okay, I think I understand why. Keep them in increments of about 360.
360. Yeah. So if the cabinet is taller than 360, it'll add a mid nailer.
Yeah.
Next.
So on a 7.
The reason why I did that, so if you go, for example, in 360, you go into 900.
Yeah, that's 2 mid
And then you add 2, and then if you go to 1080, it'll add 2. It will keep adding those increments.
All right. Next, where do you position your mid nailer? So you'll see, yeah, it'll give you the centered, above the floor, bottom, below the top. So you can say centered.
So we say above
Centered. Next, if you construct with the mid nailer into the width of the nailer, so that's also going to be 100. Next, and then that's also going to be outside back. Next, and then if you construct with the bottom nailer, what's the width? It's 100.
The only difference with the bottom one is that we're connecting to the base there.
Yeah, but you can set the connection for that as well. Now I'll show you guys now how the connections work. It works actually quite.
It will actually be for the top and the bottom.
Yeah. All right, that's not a problem. Next, where do you attach the bottom nailer? So that's going to be outside back as well. And then does your partition split the nailer? No, it's not going to attach to it. The back's going to be in the way. So partition does not split the nailer. So that's for your BIC units or such that has a solid back that has nailers in. Then if you add a partition, it automatically splits them as well. Yes. Nailer notch type for partition. You can just say through notch because that'll only come in effect if you said there partition splits nailer. So we can just skip that one over. Does your divider split the nailer? Divider does not split the nailer. And then that one also just if we said yes in the previous one. So next. And then here, which face do you want the machining on a nailer? Do you want it on the outside or the inside? If you put it on interior, it's going to be hidden with the masonite backing.
But the thing is, once you stop the backing, you got no excess. That's no good.
Yeah, and it's going to be hidden anyway, so you can put it on the exterior. And then we can just say, okay. Then we can go to partition. Define banding for partition, also just face edging. Yeah, exterior edging. Next, I select the grain direction. That's going to be vertical grain. Do you construct with a double or single drawer partition?
Well, in this case here, for the purpose of symmetry, we would use, that's a good question. Most people do double.
It's a lot safer, especially if you're...
Sometimes if you're using 22s, you can do a single. This is when you, like for example, you sit in a big cabinet and you're putting drawers in there. Say you're 49, still down the row. And you put B16. Those screws are going to start the whole thing. So that's why
It's a lot more stable.
Yeah, because it's like kind of like you got a set for the left and
It looks like you've got two individual cabinets in between.
Yes. It looks better as well.
Well, sometimes in actual fact, we can do a build up like this. 32 build up.
You can do that as well.
Yeah. Well, it is
For-
visible. So you're using 32 in this case.
Yeah, that'll just be a double 216, which gives you a 32 more.
Right.
So next, and then which face do you want the machining on a partition? We can just leave it on the left. And then we can say, okay. Now we can go to shelf. Define banding for shelf. That's going to be face edging exterior.
But you know, it's like, just go back to that, go back to that, same thing, go back to this. So there's two separate pieces?
Yeah.
Okay, so automatically, if you got the cam on the left hand side, and the on the right hand side, okay.
Yeah, they will both get their own connections. Yes.
Thank you.
Let me call it that.
It's really cool.
No, it gets really bloody cool once you start getting into the jobs and you can actually see how you can modify the units.
It's cool.
It gets better. Define banding for shelf. Okay, face exterior edging. Define banding for shelf bull nose. None. If you use if your shelf uses material with grain, you line the grain with the cabinet width. Yes. Next, and then enter the distance between the shelf and the face. So you see now here, the shelf has questions that matches the fixed shelf and the adjustable shelf. So you can do
The first part, which is divine banding, is just a next,
exterior edging on the face.
So on the top.
Yeah,
Okay.
the face. And then define banding for shelf bull nose. We can just skip over.
Okay. Now I am into the distance between the shelf and the base.
So there you can add a recess if you need to, but we can just leave it flush. And then shelf nosing option for shelf, no shelf nosing. And then which face do you want the machining on a shelf? It's going to be bottom, and that's it.
Okay.
Then we can go to a shelf nailer. Do you guys build with shelf nailers?
Say that again?
Shelf nailers.
Yeah, well, that looks like an exposed kind of thing. Say yes, you see what it does?
No, so what that does is,
That basically puts the
More support.
if you have a shelf going over, let's say 1.2 meters, it adds the nailers on the side for the shelf to lay on top.
put it in. There's nobody comes in with bigger shelves. Does it do it naturally or?
So it's gonna ask you here. Only add a nailer once the fixed shelf reaches a given length.
Okay, yeah, that's right.
So we can say there,
So you know it will go at some stage.
correct. So on this, we're going to give it a bottom edge and edging on the ends.
Yep.
Yeah.
Exterior and end exterior. We can go next. So what? Also 100 mil for the width. Next. Do you construct with a nailer for each fixed shelf? If you only add a nailer once the fixed shelf reaches a given length, specify the length. So only add a nailer once the fixed shelf reaches a given length. So what would you say is the maximum length of the shelf before it adds nailing on the sides?
It's like it's a minimum first, as opposed to a maximum. So,
Yeah, but what's the biggest size that that shelf can be before it adds?
uh, well, the biggest will be 600.
So 600. So any shelf over 600 gets nailed.
Correct.
All right. And then,
Even so fast, sorry. Make it a 300. I'll tell you why. Sometimes you're busy with the 32 and it becomes heavy.
Mhm.
Just add that for 300. Okay, double check it. You know, when sometimes you an exposed panel and it's 32, it just gives it more support. But we'll check on it.
this is some stuff that you can just weigh out over time and see what works best. You construct the nailer for each shelf. So see now here, now you have two options. You can set it so that your fixed shelves uses the nailers, but if you want to add that shelf without a nailer, you can still set it for just a normal shelf.
Absolutely.
All right. So on the, do you construct with a nailer for each shelf? I'm going to say no shelf nailer, just to show you guys what the difference is on that. Then we can say next. Which face do you want the machining on a shelf nailer? We can say exterior. And we can say okay. Now we can go to the shoe section. So this is like a shoe cut.
Pigeonhole.
Then people still
Yes, I did it. Right? Yeah, it was. So,
It works. Mostly they use it for like towels or wine racks or something. Yeah. So define banding for vertical divider. That's just going to be facing. Exterior edging. Next, then for the vertical or horizontal divider, face edging. Specify the minimum height of your shoe section. 150 by 150. Next, and then width also 150.
That's not small. I'm just going to drop this as well.
You can modify it if you want.
I'm using it as a one bottle on the
To specify the amount to extend the notches. So what this does is your notches that gets cut into the sides for them to slot into, you can add an adjustment for, especially for the tool diameter variance. So what would you say would you add there? 10 mils, 5 mils?
No, yes, normally we would use a 16 now, so just
Yeah, 5 mil should be fine then. On a 16 mil cutter, 5 mil should be fine. You use a big cutter though.
sometimes you use the bigger cutters, it does not cut. Sometimes you use a smaller cutter to prevent support.
Okay, yeah.
So if you it depends what tool you've got.
Yeah,
If you've got limited tooling, you use. But what I'm saying is, as long as you've got
you can modify that. And we're gonna, I'll show you guys when we set up the tools, you actually set up specific tools for specific things. Right, so next, which face do you want the machining? We just leave it on bottom. And then on the vertical divider, we can just leave it on left. And we can say okay. Right. Now we're going to go to the sub end. I see here your sub end and your unfinished end are two complete separate constructions.
exactly what we're talking about.
So on my sub end, we can go in, define banding for sub end, just face it all right.
exterior, bottom,
Let's say next. Select the grain direction that is most commonly used for a sub end, vertical grain. And then if you use material with one side of the with one finished side, you orient the finished side of your sub end in or out. So that's going to be in because it's going to have a snap-on panel on the side. Now that's why it's important that if you create a single face material, to leave the texture on your back of the material, like I showed you guys earlier, leave it blank. Because then Cabinet Vision will automatically pick it up as a single face material, and then this option would work correctly. Next, is your sub end full end to floor or notched for toe?
No, not
Full end. Next, and
no, sorry, it's not for toe.
is it notched for toe?
Yeah, well, in this case, yeah, okay, go back to the second one. It's full in. No,
Notched.
full end.
And cut that little notch out from the top.
Full end is only to the floor.
And what happens if we okay, we use that kind of stuff, it's fine.
Right, so full end to floor. Next, and then which face do you want the machining on a sub end? We can leave that on exterior because then it gets hidden by the slab panel.
Oh, then it normally comes on the inside of the cat. Not outside.
This is for the slab on to cover.
Oh, okay.
Now, on an unfinished end, you can leave it on the interior. See why it's important to have a sub end and an unfinished end. I say okay, then we can go to unfinished back. So banding for unfinished back is not going to get banding because it's a 4mm masonite.
Okay.
Does your construction method include an unfinished back? Yes. Select the grain direction, it's vertical grain. And then if you use material with one finished side, you orient the finished side of your unfinished back in or out. It's going to be in. Enter the space between the wall and the unfinished back. So this question won't have an effect because your nail sits at the back. So we can just skip that one over. When you have combined cabinets of different heights, do you split the unfinished back or create one unfinished back? So we can just say there, yes, split back. Next, how do you position your clipped back support, inside or outside? The default is my usual.
Okay, but not over. This is our options are listed as options.
No, two. The inside cuts a little dado into the side for this, and then outside you can then do with dowels or screws or however.
Outside.
There's two part joints and it's smaller.
And the problem is this is also a dado groove on an angle.
How do your unfinished back support?
Yeah, so there you can now say, does it connect with a miter joint so you can screw it, or does it get a dado so it gets a dado groove? So we can just leave that on miter. We can say next. Enter the amount the back support is inset. So this will be used if you say there or on this question. Oh, I accidentally selected inside. You won't have that. Never mind. Yes. Which face do you want the machining on an unfinished back? We can just leave it on exterior. And we can say okay. Unfinished end. Define banding for unfinished end. Around. Next. It's going to be vertical grain.
Yeah.
Now here, select the construction that best represents your return type. So if you build with a reaching cabinet and you have another cabinet here, do you add a filler there or do you add them flush? Right. Then you can say they build with return end filler. Yeah. Then you can just say they're blank panel return end. So then it gives you a blank panel there.
Yeah.
Then you would construe when you see Bloom also has got a flush blank form. There's some clients who want this. Then that's why you got to give them it. They don't like that wasted space in between. Exactly. But yeah, it gives us both.
Yeah, you can do both.
But this is the most common one for blank.
Yeah. So we're going to say next. Enter the amount of the blank panel that is exposed in an extended end. So what's the space there? 100. Next. And then what's the width of your filler? So 19. So that width.
No, that's 100.
100
minus 19.
100 minus 19. So we can say that 100 minus 18.
Because 18 and 19.
And then it gives you the value.
Minus 19.
Because you remember it calculates it fuller for you.
So then it gives you a value of 81. You can say next. If you use material with one finished side, you orient the finished side of your unfinished end in or out. It's going to be in. Next, and then enter the distance from the extended end case to the wall. So do you put your reaching cabinets flush to the wall, or do you leave that little space there?
Well, generally it should be, it's always left away from the wall. But there has to be how much? 50.
50. Next. Is your unfinished end full end to floor or notched for toes? Let's say full end. And then which face do you want the machining on an unfinished end? You can leave interior or exterior or where you need them. And then we can say okay. And that's then done for the interior case. We can minimize this and we can go to exterior case. Exterior case is at least not that much options. No, it's going to get busy when we get to the connections. Because then you get every single pot and how it connects to every single other pot. Right. So finished back. So finished back is your 16mm solid back. So define banding for finished back, does that sit on the inside or outside of the unit?
Inside.
Inside. So it's not going to get any edge. You can say next. Select the grain direction that is most commonly used for a finished back. Vertical grain. Does a finished back increase the overall depth of the cabinet, or do you cut all parts of the cabinet short? So depth of cabinet increases because it's going to be sitting on the inside.
Oh, okay. Okay, well, really. Yeah, okay.
And that's all we can answer there. So I'm just going to say, okay.
So your interior case is the carcass.
And your exterior is your slap-on panels, your back, your top, and all those. All your exterior, your colored panels.
So if you're doing an open cupboard like that on there, that will fall under exterior case.
That'll fall under exposed. That's why we set up the exposed material schedules.
No, the slap on panel is beautiful.
Correct. All right. Define banding for finished end. That's going to be edging all around. Next, select the grain direction that is most commonly used for a finished end. Vertical grain. Now here, select the most common finished end type for this cabinet. Do you guys build just with an integrated finished side, a panelized integrated end, a slap-on end, and a slap-on door, or just a skin? How do you know guys normally build?
Let's be complicated. Slap on door.
You want to be complicated. So what the applied door does is it adds a panel onto the side with the same your template, your wrap cut out on your door. It adds one of those.
Busy with most people on the drive.
Hmm?
They do a shake the door. You match the front, but they do not match. This is really what
That's how you match the
two
sides.
so it runs equal to
It basically adds an extra door on both sides as slap-on panels with the machining and everything as well.
and it takes the thickness of the cuts and all sorts of stuff. Yeah.
But in our case, if we're doing a square normal door like this.
Well, I'm just choosing the most I can push the boundary, but yeah,
Yeah, and if you do a normal slab door, it's just going to add you two slap-on panels on the sides. Then it's just going to be a normal slap-on panel.
So if we're doing a standard square door, it would be standard in.
Yeah, if you do a standard square door and let's say you use applied,
you can select it.
then according to what your door style is that you select is what's going to add on the sides. So if it's a slab door, it's going to look just like two normal slap-on panels.
So we leave it as
Yeah,
applied.
we can leave it. We can see how it looks for you guys.
Okay.
Next, where would you like to place the front edge of an applied end or applied door in relation with your doors? Does it go flush to your door there? Does it go flush with your sub end, or does it go flush with it like such? All right. Next, is your finished end full end to floor or notched for toe? Full end. Next, is your applied end located inside or outside the cabinet outlet? Outside. Next,
Because if you do the inside version,
it's going to shrink the cabinet.
you can also use that application to work off the best passes to be if you're doing something special. You use that function.
Yes.
Nice.
Next, which face do you want the machining on the finished end? That can be on the interior, so it's hidden away. Next, which face do you want the machining on an applied end? Interior, and then we can say okay. Then we can go to floor bottom. Define banding for floor bottom. That's just going to be face edging. Does it sit on the inside of your two side panels? So face, exterior edge. Next, select the grain direction that is most commonly used, horizontal grain. Enter the distance from the bottom of the floor bottom to the edge of the case. So do you 0, so that's always flush. Next, do you delete the floor bottom on drawer banks?
No.
So no build floor bottom. Next, if you use material with one finished side, you orient the finished side of your floor bottom up or down. Now this is a bit of a tricky one. So if you use single face material, do you orient this finished face up or down? Right. And then with your wall units? Okay. So what do we do there? Because we have two separate things now for base units and for the wall units. You see the little plus there?
Yeah.
If you press that, you can add an exclusion. You can say that, okay, for my upper units, I want it down.
Sometimes you have a single face wall Okay. Otherwise, the drawing sequence will. Okay, it's
Yep.
good.
So for default, with your base unit, your wall, your base, your tall and everything, it will always be up, and then just for your upper units, it will show. Then we can say next, highly. If your floor bottom uses material with grain, do you align the grain with the opening? No. Next, and then which face do you want the machining on a floor bottom? So once again, base units will be exterior, but wall units will be interior.
So you're bringing it from the inside.
Correct. So you can just
You
add an
want
X.
it to be close to the bottom.
Correct. Otherwise, they're going to see all that
Hands.
cam from the bottom.
Yeah.
All right. And then we can say, okay. So you guys build with the front skirt for your zinc units and such, correct?
Yeah, we were busy with the steam cabinet. We could.
All right. So the front skirt, I'm not going to set up here. There's a much easier way to do that in the job. You can just rather use the top clip and you just rotate.
Good. Good.
Right. So
It allows us to choose our own way of.
correct. So do you build with a front sink? No. That's all you do with that question. Then we can go to reveals. Enter the gap between the top door or drawer and the top of the cabinet face. 3 more. Enter the horizontal gap between a drawer and a door. 1.5. Enter the gap between the door and the bottom of the cabinet face. 3. Enter the gap between the door, drawer, and the end of the cabinet on the finished end. Enter the vertical gap between 2 doors and drawers. Enter the gap between the door, drawer, and the end of the cabinet, and the cabinet is next to another cabinet. 4.5. So you leave a 9 more gap there.
Let's see what it does.
Enter the gap between the door, drawer, and the end of the cabinet, and the cabinet is next to a taller cabinet.
That will be 4.5. The other one would be really good.
You want to go back?
No, say, okay, you go back to our home. To the bottom.
The one we entered.
This face here is 3.
Remember, so you're going to get 3, 3 now, so it's going to be a 6 more gap.
So it should be 1.5.
Correct.
Okay, so
So you're going to work it out individually.
1.5. Next, and then for a cabinet next to a taller cabinet.
That will be 1.5.
1.5.
must get 3, okay?
Enter the gap between the door, drawer, and the end of the cabinet when the cabinet is next to a deeper cabinet.
It's not 0. No.
No, this is including cabinet. So if you got a 600 cabinet and you got a 560 cabinet, and sometimes you give it 1.5. Just change it.
But then,
Just change it to 3 from 600.
You can leave it on 3.
just thinking where with the supply, we have steps, cabinets.
Yeah.
Oh, sorry, I'm thinking of such a small garage. It is big.
If you read
Yeah.
Define
the between the door, drawer, at the end of the cabinet is next to the deeper
Deeper
cabinet.
cabinet.
There's an example.
How would you have such a small space? Okay, so that's 3. Okay.
We can say next. Enter the gap between the door, drawer, and the end of the cabinet when the cabinet is next to a filler. Enter the gap between the door, drawer, and the end of the cabinet when the cabinet is next to an appliance.
Sorry, 4.5. No, that's fine. No, that's okay. Because we assuming that a customer will always ask for a slap on panel back.
All right.
Well, if they don't, they will just take it as a normal cost.
No slap on panel. All right. We can say next. Enter the gap between the door, drawer, and the end of the cabinet when the cabinet is next to a wall. 4.5. Next, enter the quantity of sliding doors in an opening.
Depends on the width, doesn't it?
Yeah, you can multiply them in the job as well if your width gets too much. Next, and then what's the overlapping value between the doors?
Well, it's going to be, it's two times the thickness. So in this case, if it's a 16 or a 32,
32.
we'll change those parameters if we read the technical.
Yes, yes. Enter the typical position of the very left sliding door, front or rear.
So generally, the one that you pull is always to the front, so that will be the rear.
Rear. Next. Okay, this we don't have to answer here. Enter the typical top door front height when there is no face frame of the cabinet. So this we don't have to answer because the runners and everything in the drawer box construction controls that. The only time this comes into effect is if you have a face frame style construction. So we can just skip that. Yeah, but then we can rather do there you get a specific panel that you can add on the front forward. So next, and then specified drawer box position, we can also just leave on default because then it'll always follow the guidelines that the runners set up for it.
No, work on the distance from drawer front bottom.
All right. Okay. We can say okay. Shadow line, we're not going to set up now. We're going to create a separate construction method for shadow line. So we're going to skip that one over. Zinc skirt, we can also just open it up and say, do you build a zinc skirt behind your false front? No. And we can say, okay, because I'm going to show you guys there's a much easier way to do that. Otherwise, it's always going to want to build that if you use that specific part. Now for toe kick, define banding for side plinth. Okay, remember that so top edge, so it's the cabinet is going to lay on the edge on the pot. We can just leave it none. Next, define banding for front plinth. Right, and then for back plinth, you just leave none. Now here, enter the distance from the floor to the bottom of the face frame. So your toe kick height is 150. And then do you construct using toe kicks or legs or both? You say they're both. What is the relationship between toe and leg? So you can set it here now to none, toes relative to legs, or legs relative to toes. What this will do is if you say toes relative to legs, your toe kick will always move according to where your legs gets placed. If you say legs relative to toes, your legs will always move relative to where your toe kicks are placed. But if you say none, then you set the position for both of them.
Well, I think it'll be good. But the thing is that you're busy with, if you're busy with a peninsula, you're busy with knighting. Well, I think you kind of set your peninsula in equal. So I understand what you're saying. Can you allow that you've got two different types of drilling before it becomes too complicated?
Two different types of running for?
No, it will be close.
Yeah.
Do that way, it's so nice now.
Next, so toes, legs offset. So from the back of the toe, 50. Next, and then enter the distance from face of the cabinet to the center of the leg. 50. Do you build with legs on the back of the cabinet? All right. Next, enter the distance from back of the cabinet to the center of the leg. 66. Next, do you build with legs on the finished end of the cabinet? And enter the distance from the outside of the finished end to the center of the leg. 80. 8.
Oh, you wanted to share the load?
You want to share? You want two cabinets to share a leg? You don't have to do that here.
Oh, okay. So then leave this as the space. Leave it at 65.
65. Because it's going to ask you here, when you place two cabinets together, will they share a leg?
Yes.
You can say there yes. Next, and enter the distance from the outside of the unfinished end to the center of the leg.
Now, this one is usually a bit tricky because the leg is supporting the carcass and it's supposed to carry, so it's that minus that. Take it. Just take it 8, make it 20.
20.
Yeah. If I remember the calculation.
Enter the distance from outside of the sub end to the center of the leg. Yeah, remember, if you have a sub end, it means there's a finished end as well.
Yeah.
There's a slap of panel. All right. What is the maximum distance between legs before adding another support? Next, enter the distance from the front of the case face to the front plinth. How deep is your toe kicks? 70. Next, enter the distance from the outside of the finished end to the side plinth. So do your side plinths get reset in, or are they flush with your finished ends? Next, and then enter the distance from the outside of the unfinished end to the end sleeper, also 20. If your construction method includes a back plinth, enter the distance from the wall to the back plinth. Do you guys build with the back plinth on your toe kicks? Okay, so we can just leave that no back plinth. Next, and then what is the maximum distance between sleeper supports? Do you guys add sleeper supports? Only furniture. Then we can just say here, never add mid sleeper. You can rather add that then manually. All right. What's the space between the sleeper supports? Right. And then which face do you want the machine? Want the machining on the front plinth? So that's going to be interior. Yeah, and then we can say okay. Then we can go to top. Define banding for top. So your top sits in between your sides. So the face exterior. Grain direction, horizontal grain. Define banding for top stretcher front. That's front and back.
Horizontal grain.
Yeah, horizontal grain.
Okay.
Define banding for top stretcher, face and back. Yeah. Top stretcher rear. You also H front and back there. Next, okay, define banding for web front. Do you guys build with web frames? It's a rotated cleat, basically. Rotated stretcher. It's not really something we do here. Yeah. Now that's your normal stretchers.
I've never seen that.
All right, so select the top type which best depicts your construction method. So base units, cleats, and wall units, full solid tops.
Not solid. So top is solid and top stretches is rails.
Right. So here we're going to say now, so on my default, I want top stretches, or actually on my default, I want a solid top. But I'm going to add an exclusion here. No, actually no. Make it top stretches for my base units. Add an exclusion for my uppers that says top. And add another exclusion for my tall, which says top. Exclusion. So that exclusion breaks it away from the default.
Okay, so for base units, you've got
Top stretches, upper, top, and tall, solid top.
Okay, makes sense.
And you can say next. If you use material with one finished side, you orient the finished side of your top up or down. So they'll technically always be down because even on your base units, you're going to get a countertop on top.
Yeah.
So down. Next. If your top uses material with grain, you line the grain with your opening. No. Enter the width of your front top stretcher. 100. Yeah. Next, enter the width of your rear top stretcher. 100. Next, enter the width of your web frame. I'm not going to build with it. Skip it over. Enter the size of your gusset. Not going to build with it. Skip it over. Enter the distance from the top of the top to the edge of the case. So your top's always flush correctly. I'm going to just leave that at 0. And then which face do you want the machining on top? That's always going to be exterior.
Yeah, because it gets covered with.
Everything on the top, you won't see it anyway. Then we can say, okay. Right, so that's interior case and exterior case done.
Oh, okay.
Operations here, very simple. You can just add line boring here for your PICs and such, but we don't really use this option anymore. You'd rather just set up a connection for your adjustable shelves that does the line boring straight through anyway.
Okay.
Because if you set it here, it's going to add that line boring to every single unit. So just go in, say no boring holes, and okay. Machining will ask you one question: are miter joints adjusted for part thickness, yes or no? All right.
That's if you're joining 116 and 120 plus a 4 meter.
Correct. And then for the last section, the connections.
Yes.
Here we're going to go through every single part and tell it how it connects to every single other part, what connection it uses,
Yeah.
and how it fits and finishes.
Okay.
All right. Do you guys want to stretch your legs before we start with this?
2 minute stretch.
So,
Right here.
adjustable shelf. So you'll see when we answer the question, when we created it, asks us for the bulk import connections. So most of these will already be answered correctly. Just a few ones here and there that we're just going to have to manually change quickly as well. So how does your adjustable shelf and finished end connect? It uses the adjustable shelf holes 3x15. So we can say next. How does your adjustable shelf and skin end connect? We can just leave on the same connection as well. Next. How does your adjustable shelf and unfinished end connect? Same connection. Next. How does your adjustable shelf and sub end connect? Same connection. Next. What connection do you apply to your adjustable shelf for a no end? This is important. If it says there for a no end, it means there's nothing on the side. There we need to say none. Otherwise, even though you can, because you can go in your construction method, or in your cabinet, and you can remove a side or a piece or such, but then the parts are gone, but the connection remains. But if the connection then drills into the side, it still drills, even if that part is no longer there.
So it almost assimilates the machine type.
It leaves the ghost part there, so the machining still drills.
Even though we're looking at it. It's a problem.
Correct. How does your adjustable shelf and finished back connect? So do you guys adjust your connect your adjustable shelf to your finished backs, or just to the sides? Just to the sides. Then there we also just say none. Next.
But then when would you put one on the
If-
back if there's weight or if it's
So-
long cupboard?
Yeah, but normally you would then rather add a fixed shelf, and then we set up a connection that just like, for instance, if you guys use that connection, you just add a single one on both sides. You don't have to get the whole run through or anything, or we just add like a dowel in the center, just that little bit of extra support if your shelf does get too long.
I actually ended up doing that in my kitchen. In the one cupboard, the top
Because it
was
goes.
boring. I had to put adjustable shelves on the back.
Yeah, you can do that. How does your adjustable shelf and unfinished back connect? None. But for stuff like that, you can rather just do it in the job itself. Next, how does your adjustable shelf and clip back support connect? Also none. Next, how does your adjustable shelf and partition connect? Adjustable shelf holes. How does your adjustable shelf and divider connect? Adjustable shelf holes. How does your adjustable shelf and shelf bullnose connect? That we can also just leave on none. And then we can say okay. Now we go to the divider.
Sorry, I think I missed
Which question you on?
Okay, so I've got the bull nose, you said none.
Yes.
And then the one before that was adjustable shelf and divider.
Yeah, that's just adjustable shelf holes.
And then partition, also adjustable
Adjustable
shelf.
shelf holes, yeah.
And then clip to back support none, unfinished back support none.
Yes.
Okay.
All right. Then we can go to divider.
Okay.
Now it gets a little bit tricky here. It's going to ask you for how does your divider and top connect. If you go here to the joint option on the top, you're going to get options there as well. So the one it's currently on, attach divider to bottom of top. But you can also tell it here now, extend divider to top of face. So if you add a divider, it automatically splits the top. So you can do that for your certain BIC constructions or such.
So you've got two pieces on the top.
Correct. Then it splits the top automatically, so the top connects then into the sides of the divider.
Okay.
But for now, we can just leave it to divider connects to the top. But now you have two sets here. Your connection, divider to top stretcher, divider to web frame, and you have alternate, top attaches to divider. So that alternate top attaches to divider will only come in effect if we set one of those two options, because then the divider doesn't connect to the tops connects to the divider. So it's according to what the direction of the machining will be. So if that's then flipped around, let me just give you an example. That would be then in the side of the top.
Yeah.
So then you need to swap it so that that goes into the side of the partition and that goes into the side of the top. Correct, you invert it. That's why that option is there. But if we know our divider is connecting to the top, stock standard, then we can say connection, divider to top over RD12. But now we have here divider to top stretcher as well, which is not going to be the over RD12. We need to go and specify the over RD12 cleats. Makes sense?
Yeah, you just can't make a mistake with this thing.
You can make a mistake,
Yeah,
just
and fix it up.
you can fix it later on, and luckily in Cabin Vision it shows you there's an issue. And if it's a big issue, it'll even give you a warning
I guess we'll see it
when you explode it. Yes. So next, how does your divider and floor bottom connect? Same thing. But now you only have your bottom and your divider, so you can set your divider to split your bottom or not, and then the connections are already set. Next, how does your divider and unfinished back connect? So that's not going to get a connection, so thereby divided by the backing groove, we can just say that backing groove is just going to be for your sides and your bottom. Next, if your divider extends to the floor, how does your divider and front plinth connect? So that's if you set your divider to split your bottom, but that's never going to happen, so we can just leave that connection on over RD12, or we can just say none. Let's say next. If your divider extends to the floor, how does your divider and back plinth connect? We can also just say none. Next, how does your divider and shelf connect? Over RD12. Next, how does your divider and fixed shelf connect? Over RD12. How does your divider and drawer stretcher connect? So that's never going to happen. So we can just say there none. And then can't say next, so we can say okay. That's divider done. Now for the drawer stretchers. How does your drawer stretcher and finished end connect? Here we just now need to go and specify it's the cleat one, because it's the 100mm stretcher one. So over RD12 cleats. Next, how does your divider of your drawer stretcher and skin end connect? That's never going to happen, so we can actually just leave that as none. Next, how does your drawer stretcher and unfinished end connect? That we can just also say RD12 cleats. Next, how does your drawer stretcher and sub end connect? RD12 cleats. Next, what connection do you apply to your drawer stretcher for no end? Once again, that has to be no. Next, select the connection if your drawer stretcher attaches to a divider. That's going to be RD12 cleats. Next, and select the connection if your drawer stretcher attaches to a partition, RD12 cleats. And then we can say okay. Now for the finished back. How does your finished back and top connect? So now here it gets a little bit tricky because it's your side parts. You can now go and specify, does your finished back extend past? Does it go flush? Does your top go on top of the finished back extended past? Or does it go flush on top of your finished back? Does it get mitered or does it get a void? So you said your top goes on top of your finished back.
The back gets recessed, yeah.
All right. So does your finished back recess in?
Generally, it's by 0.5.
0.5. So then here we can say extend top to back of case, and the value is 0.5. It'll always leave a clearance value there of 0.5.
Okay, so the clearance is within.
Right. And the connection is fine. Then we can say next. How does your finished back and floor bottom connect? Your finished back sits on the top of your floor bottom. Other way around. So then we can find the correct one there. I think it is second one from the top. Extend finished back to bottom or floor bottom. And then connection is fine, doesn't need an adjustment. You can say next. How does your finished back and finished back connect? So that's on your corner units. So that doesn't, you can either say it like that or you can put it as a mitre. And then, then just the connection is fine. Next. How does your finished back and unfinished back connect? But you won't really ever do that for a corner unit, so that won't really matter. So
No, we just add that because sometimes you're going to get these, some people still want these walking grosses with another that.
All right.
What's the different options?
So you won't be able to give any different options there. It's just the connection, but for this, it will then be a backing groove. So you can just scroll up a bit and just.
The camera down if you want to.
Yeah, but remember, your unfinished back is a 4mm mason.
Yeah, sorry, okay. I'm missing specifically some of that.
Yes, that's why you can't even adjust it here. So your unfinished back needs to connect into your finished back.
Sure.
Next, how does your finished back and finished end connect? So your finished end sits on the sides of your finished back. Yeah, so it's fine. Connection is fine. How does your finished back and skin end connect? You can also leave that as is. Next, how does your finished back and unfinished end connect? Now your unfinished end, your unfinished end, your white carcass interiors. Cabinet Vision doesn't allow you to put that on the outside of the finished back. So we can just leave that as is and just say over RD12, and then we can say okay. Right. Then we can go to finished end. How does your finished end and top connect? Your top sits on top of the finished end.
No.
On the side. No. So that should be the second option. Extend finished end to top of top. And then the connection for my top is the oval RD12, but for my top stretches, we need the oval RD12 tree. You can say next. How does your finished end and floor bottom connect? Floor bottom sits underneath it or inside? All the way around. That should be the second option from top. Extend finished end to bottom or floor bottom. And then the connection is oval RD12. Next, how does your finished end and finished back connect? Okay, now you see here, we already answered this. So a lot of these questions do get asked again if you get to that part again. So by the time we get to unfinished end, there's one question we need to answer. All of the other questions have already been answered. So next, how does your finished end and unfinished back connect? So that's going to be extend finished end to outside of unfinished back. You can just leave it like that because the cleats are already going to push that unfinished back forward, and then the connection is back.
Which one are you doing? Which option is that?
Unfinished, your finished end and unfinished back.
So it'll be option number.
That's extend finished end to outside of unfinished back, so the second from the top. Next, how does your finished end adjust when there is no back? So here, a lot of people, what they do is they'll make like the finished back a little bit shorter or longer if there's no back or anything. But we can just leave this on 0 so it doesn't adjust it.
So it goes right to the back.
It goes right then flush to the back. Next, how does your applied end and finished back connect? So that's if you have a slap-on panel.
Sorry, I missed the previous one.
How does your finished end adjust when there's no back?
Come on, how does your finished end and unfinished back connect?
Yeah, so that's the second option from the top, and the connection is backing. Okay. Got it. Yeah. Next, how does your finished end adjust when there's no back? We can just leave as is. And then how does your applied end and finished back connect? So that because your adjustable shelf is your unfinished end is going to sit there on the inside with your slap on the outside. Is that correct? That applied end is your slap on panel.
Yeah, well, it will be 0 from the back, so it will be the first one. It is.
So like it is
Go
here.
back in time, yeah, the first one.
Right. And then connection is fine. We can say next. How does your sub end and finished back connect? Now you can't put your sub end outside as well because it's part of your interior carcass, and the connection is fine.
That stays the same.
Yes. How does your finished end and nailer connect? So nailers are there, but my nailers won't use the over RD12. They'll use the one for the cleat. So we can just swap that for the over RD12 cleats. And then we can say, okay. Then we can go to fixed shelves. How does your fixed shelf and finished end connect? That's already fine. How does your fixed shelf and skin end connect? That's fine. Next. How does your fixed shelf and unfinished end connect? That's fine. Next. How does your fixed shelf and sub end connect? That's fine. Next. What connection do you apply to your fixed shelf for no end? You can just remove the connection there, so none.
Two, three, until now. 230.
Thank you.
So next. How does your fixed shelf and unfinished back connect? That we can also just say none. Next. How does your fixed shelf and clip back support connect? Also none. Next. How does your fixed shelf and partition connect? That's already fine. Next. How does your fixed shelf and divider connect? Already fine. Next. And then how does your fixed shelf and shelf bullnose connect? We can also just say that none. Right, that's the fixed shelves. We can say okay. Then we can go to floor bottom. You understand now what I meant with it's dreary. Yeah. How does your floor bottom and finished end connect? So floor bottom sits on the inside, correct?
Yeah.
Okay, that one's then fine. Floor bottom and skin end, that we can,
Go back to the
yeah, we can just take the default option, extend skin end to bottom of floor bottom. Connection is fine. How does your floor bottom and unfinished end connect? Unfinished end also on the outside. So same option, extend unfinished end to bottom of floor bottom. Connection is fine. Configure your floor bottom and applied end connection. So if you have a slap on and a sub end,
run in the same direction.
so both sits on the outside.
Yeah, that's it.
All right, and then the connection.
Not like this?
No, no, that's what you're doing.
No.
A continuous, that's you're doing modular stuff. But this one is exactly.
Okay.
Yeah.
We can just go and get the connection for that. It's going to be
And then go on.
already 12.
You see it.
Hmm.
Oh, yeah. Cool.
But that's what you do when you read modular function. But we have to.
Yeah, but you can just create a new construction method for
Copy the
modular and just change the specific things. Yeah. Next, how does your floor bottom and applied end connect? So we can just take the second option, extend applied end to bottom of floor bottom. Won't ask for a connection. And then how does your floor bottom and sub end connect? Also, second option, won't ask for a connection. Next, what connection do you apply to your floor bottom for a no end? That's none. Next, how does your floor bottom and finished back connect? So floor bottom to your finished back, that's your 16mm back, does your 16mm back sit on the top or the outside?
Say that again.
No, we answered finished back already.
Yeah, we did.
That one's then fine. Next, configure your floor bottom and unfinished back connection. That one's fine. Next, and then how does your floor bottom and unfinished back connect? That's fine. Next, how does your floor bottom and nailer connect? That's never going to have a nailer, but it sits on the top of the floor bottom, correct? Next, how does your floor bottom and clip back support connect? Clip back support sits on the top or the outside? On the inside, like such. Right. And then that's fine. Next, how does your floor bottom and partition connect? That's fine. Floor bottom and divider, that's fine. And then we can say okay. Front skirt, we're going to skip over because we don't have a construction method. Now for the nailers. How does your finished end and nailer connect? That's fine, already answered. Skin end and nailer connect, we can just skip over, that's never going to happen. Next. How does your unfinished end and nailer connect? There we can just say that over RD12 cleats. Next. How does your sub end and nailer connect? Just change the connection to over RD12 cleats. Next. What connection do you apply to your nailer for a no end? We can just say there none. Next. Select the connection if your nailer attaches to a divider. That's fine. Maybe we need to change that to over RD12 cleats. Next, select the connection if your nailer attaches to a partition. Just change the connection to the over RD12 cleats. Next, and how does your nailer and nailer connect? Also just over RD12 cleat. Next, and do you combine your nailer and back to top joints? No. So what this does is if you say yes, it cuts a little groove into your top for it to kind of slot into the nailer. So we can just leave that on no. Next, and then for the bottom as well, no. Next, and back to end joints, no. Okay. That's done for nailers.
So can I just grab this?
No problem.
Yeah. Right. Yeah. Yeah.
I'm going to clock a little bit of overtime. Don't stress too much about it. I'll let you guys close.
With the traffic being as always,
So I'm going to sleep here tonight.
it's about 2 hours. It was London. It was the first day.
Oh. Now I'm glad I left early from Pretoria yesterday.
So you were lucky.
I just missed the traffic. I think I got home out of Joburg just before 3.
But the traffic must have been holding up.
It was building up. Yeah, I just missed it.
Like if you ever do get those traffic peaks and you just wait until after 5.
I'm anyway going to be stuck in traffic and anyway get home at the same time.
If you make it 6, it just sort of opens up. You get almost basically bars.
Right, and we can go to nailer. How does your finished end and nailer connect? Already answered. Next, how does your skin end and nailer connect? We can just skip that one over. Next. No, we just did nailer.
Yeah.
We do partition. How does your partition and top connect? So we already answered this one. Next. What connection do you apply to your partition for a no top? You just need to say there none. Next. How does your partition and floor bottom connect? Already answered. What connection do you apply to your partition for a no bottom? We can just skip. I'll say none. Next. How does your partition and unfinished back connect? We can just change that connection to none. Did I lose you?
No problem.
He's doing very well given the fact that he hasn't done.
No, you're doing really well.
Genetics capacity has grown. We've had some serious training and he's done very well.
Oh, that's good. That's good.
Try.
No, you're doing good. Luckily, you guys do get the 3 months direct support. I think you just have to cover that with Christy, that for the training and such. But
Yeah.
we'll get you through it. All right. If your partition extends to the floor, how does your partition and front plinth connect? We can just say there none. Next, if your partition extends to the floor, also just none. Next, how does your partition and shelf connect? That's fine. Partition and fixed shelf connect, that's fine. Partition and drawer stretcher connect, we can just say none. And then we can say okay. Shadow line, we're not going to answer now. We're going to do that when we set up the shadow line construction method for you guys. And then we can go to shelf. How does your shelf and finished end connect? Already answered, that's fine. Shelf and skin end, that's fine. Next. Shelf and unfinished end, that's fine. Next. Connection do you apply to your shelf for a no end? You can just make that a none. Next, how does your shelf and sub end connect? That's fine. Next, how does your shelf and finished back connect? We can just set that to none. Next, shelf and unfinished back, also none. Next, how does your shelf and clip back support connect? Also none. Next, how does your shelf and partition connect? Already answered. Shelf and divider, that's fine. Shelf and bullnose, we can just make that none. And then we can say okay. And we can go to shelf nailer. So, how does your shelf nailer and finished end connect? We can just make that the over RD12 cleats. Next, shelf nailer and skin end, we can just skip over. Next, shelf nailer and unfinished end over RD12 cleats. Next, shelf nailer and sub end over RD12 cleats. Next, what connection do you apply to your shelf nailer for a no end? We can make none. Next, how does your shelf nailer and partition connect? Just make it over RD12 cleats. And then we can say okay. The shoe section, this should already all be fine actually. How does your horizontal divider and finished end connect? That's fine. Horizontal divider and skin end, that's fine. Horizontal divider and unfinished end, that's fine. Horizontal divider and no end, we'll just say there none. Next, horizontal divider and sub end, that's fine. Horizontal divider and partition, that's fine. Horizontal divider and divider, that's fine. A vertical divider and top, that's fine. Vertical divider and floor bottom, that's fine. Vertical divider and shelf, that's fine. Vertical divider and fixed shelf, that's fine. And then we can say, okay. Zinc skirt we're also not doing, so we can skip over. Skin end, we can also just skip over. And then the toe kicks, you said, how are you going to connect them? You're just going to leave them open. Okay. Then we can just skip them over. And then for the top, how does your top and finished end connect? Already answered. Next. Top and skin end. Next. Top and unfinished end. Already answered. Next. Top and applied end. Your top, okay, that's answered. Next. Top and applied end connect. Answered. Top and sub end connect. Answered. Top for a no end. We can just say there none. Next. How does your top and finished back connect? Already answered. Top and unfinished back connect. That's fine. Top and unfinished back connect. That's fine. How does your nailer and top connect? That's already answered. Next. Top and clip back support. That's fine. Top and partition. Answered. That's fine. Top and divider. Answered. Next. Top stretcher and top stretcher. So here we can just go and add the overall RD12 cleats.
This is for the last one. And
That was the last one, yeah.
the structure.
Then we can say okay. Then we can go to unfinished back. Unfinished back and top, answered. Unfinished back and top connect, answered. Nailer and top connect, answered. Unfinished back and floor bottom connection, answered. Unfinished back and floor bottom connect, answered. Floor bottom and nailer, that's fine. Unfinished back and finished end connect, that's answered. Unfinished back and skin end connect, that's fine. Unfinished back and unfinished end, that's answered. No, that needs to go to the third option. No, last option. Second from last. Extend unfinished end to outside of unfinished back. Connection is fine. Unfinished back and applied end connect. We can just take that to, I think, the second option. Unfinished back to the sub end. And then connection, we can just make the backing groove. find it. Back in groove. Next, unfinished back and applied end connect. We can just take the second option to keep it flush. Next, how does your unfinished back and sub end connect? We can just also take the middle option to keep them flush. Next, and what connection do you apply to your unfinished back for no end? There we can just say none. Next, unfinished back and unfinished back, we can just leave as is. Next, unfinished back and partition, answered. Next, unfinished back and divider, answered. Next, unfinished back and fixed shelf, that's answered. And then we can say okay. Now for the last one, unfinished end, we only have 2 questions to answer. How does your unfinished end and top? Answered. Next. Unfinished end and floor bottom, that's answered. Next. Unfinished end and finished back, answered. Next. Unfinished end and unfinished end connect, that looks good. Connection is fine. Next. Unfinished back and unfinished end and unfinished back, that's answered. Unfinished end and nailer, that's answered. Sub end and nailer, that's answered. And then that's it. That's a construction method.
2 hours and 21 minutes.
Yeah, but remember that's with the connections that we made. All right.
So what would we have to revisit?
You got it?
All right. You guys happy with that?
That will work.
All right. So it's not difficult. It's just a lot to do. Yeah, it's a lot to do. So
So save the changes.
okay, save changes, and then we can close that. Then I'm going to show you quickly how to create the doors, and you can go and play around with that a bit.
Okay.
The doors. I'm going to show you quickly how to create the doors. That's the last piece for today. Then we are done. And then I just want to copy you over the training videos and everything as well, so that you guys do have that as well as the test. But I am going to remove some of the stuff out of your test as well, especially with the doors and the machining for the template doors, because you can't do the wraps and everything yet because the tools and the machine isn't set up yet. So we can rather fall back on that at a later date. Right. So for doors, I'm going to go into the door catalog here, and I'm going to go and say the new. Okay, no, before I do that. So under man-made, you'll see there is a folder called training. There should be one.
Sorry, DJ, you went into doors.
Doors, yeah.
Okay, mine is showing me this thing. Oh, this. Okay.
You know, right. You can go there to man-made. Under man-made, there should be an option that says training. Right. Otherwise, just select the man-made folder.
Okay.
Right-click on it.
Yeah.
Top option, create folder. Just create the folder and then just rename it to training. So I'm going to show you quickly how to create the 3 different types of doors. So to create it all, make sure you select the correct folder and you say new on the top left corner. And then by name, we can just call this slab training. The description, we can just make the same. And then you'll see now there's 3 options: a slab, multi-piece, and a template. So a slab is just a dead normal slab door. Gets handled, gets hinges, that's it.
Okay.
So tags and notes, don't stress too much about that right now. It's not really something you're going to use. But for the notes, you can add little notes that pulls through to your reports and such if you need to give special instructions for the specific door to the manufacturing and such. And then design, you can specify is it for a door or just for a drawer front. So if you select your design door, it's going to create this door to be able to use by your drawers and by your doors. If you say drawer front, it will not allow you to use this as a door template, only for drawer fronts. So just select door and it'll be used for everything. Then we can say next. Then here by style, on the drop down, you can select a few different styles. You can select chamfer, radius corners, and inverse radius corners. Just note that this will, on the slab doors, that is just design purely. It won't cut, it won't machine like this or such. That's why we have the template doors. So for the slab doors, we just leave it on none. And then we say finish. Right. You'll see there's your slab training. Does yours look like this? Yeah. All right, it's cool because a lot of times it looks like this. Okay. So double click on the slab training for me.
Yeah.
Just want to run you through all the settings for these doors. So this is the properties that you can now go and modify for this door again. So you can go and change the name, the description. You can add a tag to it. You can change the unit cost or the cost per square meter if it's a buyout door. And then edge band. Here you can go and designate on your left, right, top, and bottom edges. What does it get? Does it get door edge banding, none, or veneering? So on your template doors and such, your wrap doors, you will always say on that specific door, none. So it takes the door edge banding off. All right, makes sense. But for your slab doors, door edge banding stays on. Edge profiles, here you can go and specify, is it a finger pull, an outside edge, or does it get nothing? So outside edge, you just normally leave on for your template doors, your slab doors, something, then they'll always get their edge banding and their groovings and everything on if you assign it to them.
Okay.
Sorry. And then you can go and create a finger pull profile to add on that middle of the door. When these cases mostly it's anyway just aluminium finger grips that people just put on. All right. Defaults. Defaults is the starting specifications that this door will always come out with. So you can give it a default material schedule, default outside edge profile, inside edge profile, raised panel profile, finger pull profile, and root path profile. Now, these profiles are what I'm going to show you guys when we set up the machines so that we have the tool paths of the tools and everything to create the profiles. That is set up usually here by the root path profile and the outside edge profile. So I'm going to show you how to do that once we got the tool set up and the door set up, the machine set up and everything. Okay. One more thing that I want to show you with the slab door. Material schedule. If you go here to the three dots on the side, it'll give you a list of all of the material schedules available in that we set up so far in Cabinet Vision. Now, a lot of specific doors are meant for specific material schedules, and you don't always want to go and rummage through the whole list. What you can do is you can go here on top to the material filter, go and check here on the left for your material schedule for your door. So that would be right at the bottom, the training door schedule.
Yes.
Select it, and then the arrow on top that points right,
Okay.
select it. You'll see it adds it to the right.
Yeah.
And I'm going to say close, save changes, yes. And now you'll see by my material schedules, that's the only one that's available because it's filtered out. If you don't have any material schedules filtered out, it'll give you the whole list. But there you can go and filter out all of the specific materials. That's why with our PG Bison doors and everything as well, the PG Bison Fusion door has all the Fusion colors. The Madeira door has all the Madeira colors, and so forth and so forth, just to keep it a bit more organized.
Keywords can still, I mean, for example, if you type in Fusion, for example, does it bring up Fusion first as all the colors?
Yes.
So it is keywords.
It's keyword sensitive, yes.
Oh, it's fine, also.
Right. So that's a slab door. Simple, straightforward. It's just a block slab door. So what we're going to do now, I'm going to say, okay, save changes, yes. Bring me back to this. Then I'm going to say new. I'm going to name this training multipiece. I'm going to select my type for multipiece.
Is that like a 5-panel?
It's your multipiece, with your rails and your glass inset panel on the center and such.
Or like a 5-panel sheet?
Yes. So tags and notes we can skip over, and then design door, and we can say next. Now here, it will ask for your type. So here you can go and say, does it get a raised panel? Does it get a flat panel? Does it get a glass panel? Does it get horizontal slats, vertical slats, or just a slab inset? So I'm going to go and say glass. Second option is the panel inset. So the grooving that it cuts into the side of this stile, how deep does that need to go? So you can just set that to 8 mil. And then your left stile width, so it's the stile width of your parts, you can just all make that 75.
Makes sense.
I'm waiting with the option. Choose the one I have in mind as well.
Yeah. Do you want to miter it or not?
And if you were to select this as a mitered joint, so the drilling of the mitered joint, does it allow you to do this drilling?
Yes, if you have a point-to-point for it and such, you do. That's why in your connect.
Connect this into machine function as well.
Yep.
Okay.
So, but for now, we can just leave it as a butt joint, and we can say finish. When you go double-click on that
What
train,
happens if you want to do it as sorry, to do the door as a proper fielded raised panel?
Mhm.
Instead of the machine.
that depends on the machines that you have
That's
available.
how you go to molding as well.
A molding machine, a manual molding machine.
No, automatic molding machine.
I've never integrated with one before.
With the nesting machine.
With a nesting machine, yes. If your nesting machine is capable of cutting it, then yes, then it should be able to do that. Yeah.
When you should do it with that tool, you should do it with that tool. It's not with the 5%
So, yeah, I've had some customers tell us that they prefer a solid 16 with a stream of cutout because for stability, especially on long walls, they have
So you guys also do it a 16 mil panel with 3 mil panel on top.
Yeah.
Right. So in cabinet vision, it's not really built in to create the shaker like that. Yes, but we wrote to UCS that builds that all for you and output it for you to your machines.
So you get both of them done exactly the same as opposed to sticking on so many.
Good. Right.
But this is actually still okay. So at least we know the problem is as flexible as you want it.
Yeah.
Yeah, once you guys get to the shaker door setup, and I'll show you guys all of that when we do the template doors and such, when we get your tools and your machine and everything.